We're going to start chapter 10 today, which is over the area of polygons. I know in the past you've already found the area of rectangles and squares. You've also found the area of triangles, which is just half of the area of a rectangle or a square. So you should know the formulas for those, but we'll refresh our memories. So the big idea for this chapter is that we can find the area of polygons, and that we can find those by dividing them into smaller shapes and then combining, which would be adding the areas of those smaller shapes to combine them into the larger polygon. So those are known as composite figures. We can apply these truths to math. We know God is without error. He is truth. He created the world, and that obviously math is the language of science, and science is the study of God's creation. We know there are correct or incorrect answers to math problems, but there's many ways to reach the correct answer. We're going to see that a lot this chapter. We know that parts can be combined to make a whole, and we can also think of parts and whole in math, remembering that which is broken apart can be made a whole again, reminding us that God makes us whole when we are broken. We have recall prior knowledge that you guys should have checked from yesterday. So this should be 120 square meters. And then number 2 should be 100 square centimeters. 3, you should have RU, or you could have UR is parallel to ST, or you could have TS. And then the other set of parallel lines would be SR or RS is parallel to TU or UT. And then the name of this one would be a rhombus. And then this one, number 4, would have been a parallelogram. You should have EF is parallel to HG. And then EH is parallel to FG. And then you have a trapezoid on number 5. And JM is parallel to KL. So there's not a second set of parallel lines on number 5. So some of you know, just based on the recall prior knowledge, that you might need to work a little bit on some information from before this chapter. So if we go into lesson 1, we're going to specifically be using formulas, or a formula, to find the area of a triangle. You can see there's some vocabulary words from this lesson. And on page 75, I believe it is, they are showing you that you can find the formula for the area of a triangle. So if we have a rectangle that we draw, you can split any rectangle into 2 equal triangles. Okay, so if I know the area of a rectangle is length times width, I can also write the area of that rectangle. Another way to write it would be base. This could be the base, and that would be the height. So the base would be the same as the length, and the width would be the same as the height. And if I just wanted to find the triangle, you can see that it's half of that. So I could take base times height, and it would be times 1/2. Or you could say I'd divide it by 2. So I'd do base times height divided by 2. Okay, and the reason that I want to do base and height is because sometimes you'll have triangles where they might give you something like this, where that actual height is not an actual side of the triangle. So we can't call it a length or a width, but we have to call it a height that we don't have the actual height of. We don't have an actual side of, so it can't be the width. So we have this is the base right here, which would just be this distance, but not the whole thing. And then we'd have to go make a right angle. And then the height would be the distance off of the base. So it's where it meets the base at a right angle and then connects to the opposite corner, which is right here. So then we use the formula base times height, which I could complete this into a rectangle, which I would have there, and I could say that that is 1/2 of that rectangle that I just drew. So it would be base times height divided by 2. So if I told you this was 6 and this height was 8, I would do 8 times 6 and either times 1/2 or divided by 2. I find lots of students like to use this formula better because they don't end up having to work with fractions. They can just do 48 divided by 2 and get 24. Whereas if they use the 1/2 base times height, it will be 48 and then times 1/2, which is really the same as divided by 2. And if you're working with area, you're multiplying one dimension times another. So it would be whatever the unit is squared. So if it was feet, it would be square feet. If it was meters, square meters, and so on. Okay. So remember the base has to be an actual side of the triangle. Okay. So this right here cannot be the base, even though they give us the dimension, because it's not an actual side of the triangle. Okay. So this 10 right here that they labeled is my base. So I would label this B for base. If you label it with a capital B, it will get counted off. We will be using a capital B later, which you will find out what that means. It's the area of the total base of a figure when we start figuring out volume. But for now, you need to use a lowercase b for the edge length of a base. And then the height, it forms a perpendicular, which is a right angle, from the opposite vertex and then to the base. So it's wherever it meets the base, so right there, and then it goes to the opposite corner. So here's the opposite corner to the base. So that would be right there, and that's that 14 centimeters. So this would be our height, which I would label with a lowercase h. And then remember our area of the triangle formula is 1/2 base times height, or I can use base times height divided by 2. So then I just fill that in. So if I do base times height divided by 2, that would equal 10 for the B. And then the height would be 14 divided by 2. So 10 times 14 is 140 divided by 2 is equal to 70, and these were all labeled with centimeters, so 70 square centimeters. If I use the formula 1/2 base times height, it should work out to be the same. 1/2, and then the base is 10 times the height of 14. So remember the associative property of, or the commutative property means I can switch the order, so I could do 1/2 of 10 first. So 10 times 1 over 2 over, so I can do this, or I can just do half of 10. Well, I know that. That would be 5 times 14. Or if it would have been easier for me, I could have done half of 14 is 7, and 7 times 10 is 70. So it's 70 square centimeters. So either way, whichever formula version I use, it still is the area of a triangle. Okay, you can pick one of these to do for practice, and then we'll check it. So I'll give you about a minute and pause the video. Okay, so if you did number 1, you would have gotten 20 square units. If you did number 2, you would have gotten 6 square units. If you did 3, you would have gotten a decimal of 1 8900 square centimeters. And then number 4, you would have gotten 4 5900 square feet. Okay, maybe you did more than one. Okay, and the next one is to find the height of a triangle given its area and base. So really all you're going to do is know that you have the area of a triangle formula. Okay, In this instance, they'll be giving you the area, and then you have to find one of the other variables. So regardless of what they have, if you have your formula and you write down your formula, and then you substitute in what you know, so the key will be substitute what you know, and then you just have to solve for one variable. Okay, so for instance, if we look at number 5 on the guided practice, it says the area of triangle JKL is 35 square meters. So I have area equals base times height divided by 2. So we know the area is 35, so I can fill that in. It says find the height of the triangle. So it gives me this figure that looks somewhat like this. So I have K, L, and J. And it says this is 7. And it says, what is this? Okay. So we know the base is an actual side of the triangle, so that has to be that. And the height is coming off of the base at a right angle, which would be that right angle right there, which they even labeled for you. So I know the base is 7. I don't know the height, so I'm going to leave it as an h, and I'm going to divide it by 2. Okay. So then I start to solve it algebraically. I'm just going to isolate the h, so I need to get everything else to the other side. So this is division, so I'm going to multiply times 2. So that gets rid of that. So then I end up with 70, because 35 times 2 is 70, equals 7h, because the 2 and 2 canceled out. Okay, then the next step is still isolating the h. So I'm going to divide both sides by 7 to get rid of that, because this is multiplication, so the opposite is division. So 7 divided by 7 is nothing, so this would be h is equal to 70 divided by 7 is 10. And then I could even check it by plugging it back in. 7 times 10 is 70, divided by 2 is 35, which is the area. So it checks. I need to label it still. So my label would be 10. So that's my number. And then is it meters, square meters? So this was labeled 7 meters, so this would be 10 meters. So we're not working with area, we're working with the height in this case. And then you do the same thing if you were looking for the base. You would just fill it in, and if you were looking for the base, you'd just isolate the base instead of the height. So for instance, number 6, it says the area is 36 square inches. So we know base times height divided by 2. And it tells us we don't know the base, but we know the height. So we have 8 divided by 2. Okay, you can also do this and simplify it this way. So it would be 8 divided by 2 is 4. So then I have 36 is equal to base times 4. So then I can divide both sides by 4 and get my base is equal to 9. And those are labeled inches, so it would be 9 inches because it's not area again, which would then have the square label. And that is how to find the area of a triangle, the height of a triangle, or the base of a triangle.